Hello everybody. This is the notes for, we're not really doing sections, this is the notes for area of a regular polygon. There's going to be a bunch of people absent on Friday because they're skipping or whatever reason. And so I'm just putting this up here for your reference. So, talking about the area of a regular polygon. So, regular polygons, all sides are the same. What we're going to do is, from this center point, and the same is going to be true for all of the any kind of regular polygon, whether it's 6 sides, 5 sides that you see on the right side of the screen there, the same process will always work. So, you have a center point, center of the regular polygon. I'm going to connect the center point to each of the vertices. Now, because it is a regular polygon, these are all going to be the same length. Because it's a regular polygon, those are all going to be the same length. All the sides are the same length. So we got 6 equal triangles. To find the area of this, what we're going to do is find the area of each of those triangles. So, if we make the side, I don't want to use A there. If we make the side of the regular polygon the base, the height is going to be coming from the center perpendicular to that. Now, because it's a regular polygon, when we draw in that segment coming from the center perpendicular to that side, it's going to cut it into 2 equal parts. Okay? So it's going into the midpoint. We're going to do that same thing for each of these triangles. Now, because it's a regular polygon, those are all the same. Okay, they're different from the red one-tick segments, but they're all the same. So what I'm going to do is call that side length A. So they're all A. This segment A, it is called the apothem. Apothem. It's defined as the distance from the center to the midpoint of the side of a regular polygon. So, they're all the same. Those are the apothems. Now, I'm going to name each side of this regular polygon a different letter. Even though they're all the same length, I'm just going to use different letters, and you'll see why in a little bit. So, we already got A, so let's go with B, side C, D, E, F, and G. So, the area of this, it's going to be the area of each individual triangle. For this first triangle here, the area of it is going to be 1/2 the apothem times B plus. And now I'm just going to go around counterclockwise. Next triangle is 1/2 times the apothem times side C plus, to keep on going around to the next big triangle, 1/2 times the apothem times the base of D, plus 1/2 times the apothem times E, plus 1/2 times the apothem times side F, plus 1/2 times the apothem times side G. We have 6 individual triangles. When we add up all of those areas, that is the area of this regular polygon. But if you look at all of these terms, you have 1/2 times A, that apothem, in each one of these terms. What you're left with is B plus C plus D plus E plus F plus G. So, what does the sum of those 6 sides really mean? When you take side B plus C plus D plus E plus F plus G, that's the distance around the shape. That is the perimeter. 1/2 times the apothem times the perimeter. That is your formula for a regular polygon. Okay? So, using that formula, and again, the whole idea, when we're talking about area, the dimensions we use, they have to be perpendicular to each other. The apothem is perpendicular to the side. In each of those triangles, that apothem is going to be perpendicular to the side. We're just adding up a whole bunch of area of individual triangles, putting them together. The side is the perimeter. but the apothem is always perpendicular to those sides. So that's good. Now, this is the formula. So we need to know the apothem, and we need to know the perimeter. So every shape is going to be different, but there's going to be some similarities. Okay, so I'm looking at this regular pentagon now. We've got this center point. What we're going to do is draw in the point of the segment from the center to a vertice. We're going to refer to that as a radius, because if you draw a circle around this, the circle will be going through that point. And we're going to draw in the apothem, and that's forming a right triangle. Okay, now what's special about this right triangle? What's special about it is a right triangle, but this is going to give us all of the information that we need. So if I draw in this other radius, this angle right here in red, you know, with this, what we have is, if we go all the way around the circle, we got 5 of those angles. So if you take 360 divided by 5, that's 72 degrees. That's the measure of this angle. Okay. Now, again, we're going to be concentrating on this blue triangle. When you draw in that apothem of the bigger triangle, it cuts it in half. So now that's a 36-degree angle. So we're concentrating on this right triangle where that's 36, our apothem. Remember, the apothem, it goes to the midpoint. So if our side is a length B, this side of the triangle would be half of that. Now we got a right triangle. Okay, this triangle is the most important thing. This is where you're going to get all of your information and where you're going to do all of your work. What changes is, what information are you given? Are you given the apothem? If you're given the apothem, you need to figure out the perimeter. So then you would need to know this. If you're given the radius, that R value, you need to know the apothem and the perimeter. So everything is coming from that right triangle. So how are we going to get that information? It's a right triangle, Pythagorean theorem. If you got a 30-degree, you got a 30, 60, 90 triangle, you got a 45, 45, 90 triangle, you got those ratios of side lengths. In this case, we would have to do some trigonometry to relate the 36-degree angle to whatever sides we know. So you need to know your sine, cosine, and tangent ratios, because you're going to use all of them eventually, depending on the given information. Okay, so let's look at this example. It says find the perimeter and area of the irregular polygon, round answers to the nearest tenth if necessary. So let me make this a little bit bigger. It's a little bit blurry, but I'm going to draw in the apothem. We need to know that number. Okay, what we're looking at is a regular hexagon. So if I draw in this thing, what we have is an angle there. Okay, we have 6 sides. So 360 divided by 6 is 60 degrees. I'm going to cut that in half. It makes this angle 30 degrees. So just off to the side, I am going to redraw the right triangle, the main one. We know 8. We know 30 degrees. We need to know the apothem, and we need to know that side x, because we need the perimeter. So this is our x right here. Now remember, the apothem, it goes to the midpoint. So that's also an x and x there. Okay. With a 30-degree angle and a right angle, now we're looking at a 30, 60, 90 triangle. We know the hypotenuse is 8. So x is going to be half of that, so that's 4. The apothem is the longer leg. That's the shorter leg multiplied by square root 3. If x is 4, and that's 4, we have a side length of 8. Okay, so our perimeter. This is a regular hexagon. We have 6 equal sides, all of length 8. So our perimeter is 6 times 8, which is 48. So there's part of our answer. We want to know the perimeter. Now the area, 1/2 times the apothem times the perimeter. The apothem was the 4 square root 3. The perimeter is 48. You do that multiplication, you got your area. in units squared. Whatever 1/2 times 4 times square root of 3 times 48 is, that's our area. And I'll let you do those calculations, okay? But that's the idea of how these problems work, okay? You're concentrating on this right triangle. What you do to get the needed numbers, the apothem and the perimeter, it depends on what you're given. It depends on how many sides. You know, if this was not a 30-degree angle here, let's say it was that pentagon where that was a 36-degree angle. We know the hypotenuse. We need to know x. So from the 36-degree angle, x is the opposite side, 8 is the hypotenuse. We'd be talking about using the sine of 36 to equal opposite x over hypotenuse. To get the apothem, that's the adjacent side. We still know hypotenuse. So we will use cosine of the angle to equal adjacent side, the apothem, over the hypotenuse. Okay? You've got to be looking for those trig ratios. Look for your 30, 60, 90 ratios. Any information you can use based on that right triangle. That's how you're getting your answer. Have a good night.